So mostly we will discuss mostly topics based on the microservice architecture in this agenda. So microservice architecture, mostly guys are aware about that, how we can use that architecture, and be- but this architecture have multiple challenges with the along with the benefits. So one of the we can see how we can decompose the application. If you have how we have an idea, so how we can decompose that idea to design a application based on the microservice. So we will discuss how we can decompose our applications, and how we can handle cross-cutting concerns. So there are a lot of cross-cutting concerns, and when we'll be working with the applications. So there are a lot of cross-cutting concerns, how we can handle the configurations, how we can handle logging. So these cross-cutting concern, I will try to cover some of them, but because cross-cutting concern one of the very big topic, so we can't discuss in a single event. So we will discuss these topics in details in later our events. So microservice deployment pattern, one of the things, how we can deploy our microservices, uh, how we can use BM, how we can use container-based technologies like Docker and Kubernetes. So we will discuss some theoretically here, but in this event we're not going to in detail. So as I told you, this is a high-level agenda what we are going to discuss. So we will discuss these topics in details. We will organize more events based on the particular topics, and we will see practically much I can. So inter-service communications. So microservice, because it's a distributed based application, so how we can communicate these services, which patterns we can use to communicate these services to avoid failures, cascading failures. So in this inter-service communication, we will discuss some patterns, and also we will discuss service registry and discovery patterns. So service registry and discovery patterns, we will see how we can register your service with the server, with that cloud, and how we can discover this particular registered service from that cloud. So we will see some patterns here, and how we can handle the load balance based on the traffic. So, and testing of microservices, testing is one of the very impactful area of any software architecture. So testing must be very well performed, very well, and how we can easily perform the testing. So testing is one of the very crucial part of any software. So we will see some testing things, how we can test our microservices, because testing of monolith application very different, and testing of microservices very challenging for microservice based architecture. And we will also see some microservice anti-patterns. So anti-patterns, actually we will see what we can use, uh, what things we have to focus to design the microservice architecture, and what things we have to avoid whenever we are designing to the microservice architecture. So in this particular topic, we will discuss what things we can avoid to use in a microservice architecture, because in initial level we can use some small things in our service, but after code base is increased, so this problem create the very big problem actually. So these are agendas we are going to discuss, right? So I think I got the lot of mail from you. So uh, so one by one I can you can introduce yourself one by one. So I'm just taking names, so you can just introduce yourself. Just give me a minute. So Gyanendra, just give me
Yeah,
some words about yourself. Just mostly one line or two line was only.
hi all, this is Gyanendra Singh Mall. I'm living in Noida. I have around 8 years of experience in developing web-based applications on Java and JEE and domains like media and marketing, sun identity and access management, healthcare domain, Internet of Things and BFSI domain.
Okay.
Thanks.
And Jay sir, Jay Vardhan.
Uh, yeah, good afternoon, everybody. CJ. I have overall 20 years of IT experience, and done a bit of everything: development, production support, on-site project management, implementation. I also have SAP experience about 9 years, and now again I'm coming back to development. So that's it about me.
Arjit.
Hi all, my name is Arjit, and I live in Delhi. Currently, I have 6 years of experience in Java, and I am currently working with Amdocs.
Okay, thanks. Himanshu. Himanshu.
Hi everyone.
Yeah.
Myself Himanshu Pant. I live in Gurgaon and working with a growing company. And so basically I worked in the front end technologies and somewhat good experience in the Node.js and Angular for the backend.
Okay, thank you. Kishore.
Hi all, this is Kishore. I'm staying in Chennai actually. So I'm having 5 years of experience in linear programming. Now I'm shifting to the web programmings. So that's my side.
Okay. Narsimha.
Hi all, this is Narsimha. I am from Chennai. Yeah, I have around like 8 years of experience in Java. Yeah, but actually I'm seeing like Rajput tutorial like website regularly. That
Yeah.
is where I get impressed with his tutorial. Yeah, that is the reason.
Okay.
Like I would like to learn something from him. With personally, that is the reason. Like today we are here. Thank you.
Okay, welcome. Tulsi.
Hi, Amish. I'm Tulsi. I'm living in Bangalore. I have 8 years of experience in Java and other technologies. So I started to work on Java Swing application. It's like a desktop application. Then I moved to EJP.
Hmm.
After that, Studs, then Spring Boot. Currently, I'm working on Studs.
Okay.
Now I'm going to learn this architecture level. So I want to know completed deployment, how it will be.
Okay.
Yeah, thanks, Dinesh,
Yeah,
for
thanks.
this chance.
Last one is Stan. Stan.
Hi Dinesh,
Yeah.
myself Shanmuraj, working in a payment-based company in Chennai. So
Okay.
currently I'm working as a technical lead there and working with application which is developed with the Spring.
Mm.
And for APIs we have used the Spring Boot. So what we plan now is we are revamping our application, like web-based application to microservices with the Docker and Kubernetes. That's we are in the very early stage. We are doing the groundwork for that. So I'm just following you in the group as well as the site. So I learned so many. Just want to understand from the architecture pattern how I can re-architect it, because since it is the first one, I just want to define couple of services. With that, I want to touch how it is can be deployed, how it can be scaled. So that is why I just came over here, and I thought you could help me out on that.
Okay. Thank you. Thank you guys
Thank you.
for your introduction. So let's start. Okay. Let's start with the monolithic application. So as we know, a monolithic is a simple application. Just we have, you can see, we compare with the 10 year ago, how we can design our application. We are designing a business, when we have idea and a business about a business. So how we can design our application. So we just put all things in a single artifacts and we are creating application. Even either we are DAO layer or service layer or security layer, or we can say any business component like business related things. Either we can see, just suppose we are considering here one application that is called account management system or customer management system. We will try to say like how we can customer go to the bank and open an account. So that's a bank management system, and we can say bank management system, or we can say a application that is a book e-commerce company. Like you can purchase the book from the particular website. So we can consider some theoretical example, and we have the practical as well. So we will see. So suppose we have an application that is an online book portal. So book means we can purchase a book from a online portal. So we just fetch the book name by title or ISBN number, and we can get that book, and we can just check the inventory available or not, and after it available we just purchase, and book has been ordered. So that is simple high level application we will consider and see how we can organize that application in a monolith. So if this application, if you want to design in a monolith, so we have multiple component like inventory management system, customer management system, or shipping management system, or order management system. So these are actually one of the component we are trying to manage as a business collectively. So in the monolith application, we just put these all component as a single artifact, and we are creating application. So monolith application is a single artifact, all layers, all interfaces in a single artifact. We just include and design an application. We are not care about how we can scale the particular component. We are not care about that on that time. We are just focusing on the business goal, what we are going to give the input and what we want as a output. We are just focusing on that particular. So if you have already much aware about that 20 year of experience at on that time, mostly application as a monolith. So we are creating a big wall of a application. We are handling that big wall. Whenever we want to deploy that, we need a lot of time to deployment, and 100% we will take like 1 hour or 2 hours as is shutdown time whenever we are going to deploy. So on that time the monolithic is very popular, and we are use that type of application architecture. So this is actually monolithic bookshop, online bookshop. If you are going to create the application in a monolith, so you can see here. So this particular box, like UI layers, like if you want to generate a shop front UI, if you want to create either JSP or any technology if you want to use, so you have to put that UI component in a single artifact along with the account service, order service, book service, book or inventory service, or like shipping services. So these are actually high level of we can include a lot of more, but here I'm taking only 4 modules. We can say shopping cart module or any more might be there. So these module we can just create a single artifact, and a big war file we have to deploy in a Tomcat or any container based any Tomcat Java container like JBoss, any server. So any type of client like desktop, mobile, or browser, it's only one way to communicate, like one Apache servers, and just communicate through the Nginx by, if you have load balancing. If you have multiple server, then we have to use that. And single database, either it's a NoSQL or SQL database. So that is actually traditional web application monolithic architecture if you want to use monolithic. So monolith actually on that type have some advantage as well. Like if monolith application is a small application, suppose you can design a small monolith application. If you have a startup, you have less amount to be spent. So you can choose the monolith architecture, and it is good when it is small. And it actually maintainability, if any monolith application is small, it's a maintainable, simple to develop. Testability is simple to test, because if monolith application is very small, then we can test easily. Similarly, deployability and scalability, we just increase the number of server, we can horizontally scale that particular application. But always a startup not is always is a single, like a small companies. It might be like a big company, because I have started with the Paytm. On that time there are 2 member with the Paytm, me and my lead. So we are creating the application as a monolith application in the Paytm. So near about 10 years ago, 2010. So I have created that application, Paytm for mobile recharge website. We, on that time, there no concept of wallet or e-commerce. There's only prepaid mobile recharge. So that time, the company was very small, the part of 197 Communication Limited. So on that time, we have created simple, a small application that is only provide the prepaid recharge. Then we have introduced postpaid recharge. Then we have introduced DTS. But then we have introduced wallet concept. So that means we are increasing our application. So the time is whenever we are increasing the application, we have to decide to break that application in multiple things. We have to create that application based on the business capabilities. So if monolith is not a small ball, then what challenge you might face? That maintainability, as you discuss here, simple to develop, but in case of small, but if it's not a small ball, then maintainability is very difficult because the large and complex code base give the problem, because we have lot of module, lot of domains, lot of developers. So it is very difficult to maintain. There are a lot of complex code. Some developers might be very experienced, some developer might be less experienced. So the conflict and duplicity of the code might be there. So that maintainability is very difficult when monolith is small, not a small ball. Testability, if maintainability is increased, then testability will also it's actually required manual effort. Why? Suppose we are releasing a monolith application, a big monolith application, and we have introduced one small feature on a particular domain, particular component, but you have to test whole application because the impact you don't know where is give the impact. So you have to check whole module as a single entity and check into integration again whenever we deploy that application. So testability is required in that case, much required. Deployability not easy because if that single wall is very big, then deployability might be not too easily because of shutdown time, because you have a good business, but because of your deployability you have to make your application shut down for 2 hours. So you can't make it deploy like frequent. You can't change rapid in your application. So there are two company A and company B. Company A actually build a application that is based on that architecture. We can easily rapid deployment, frequent deployment. So, and he can introduce lots of new feature in a few days. But if you have monolith big application, you just like you could try to introduce new feature, but you just afraid because of downtime. You have to your application might be set for 2 hours, so you lost the business. So deployability one of the challenge for monolith if a big wall. And scalability. Scalability, if you can see, if you increase the number of server for a particular application, so you can just scale your application, either is big or small. So in case of a small ball, it's also scalable by increasing the number of server. Here is also scalable, but what is the difficult to scale here? If you want to scale a particular module, suppose one of the module is generating a lot of business, so you need to introduce some resources, extra resources to that particular domain, so you can't do that. And also if you want to make some component that is have new advanced technology, so due to conflicting of resource, it will be like give the problem. Like you can see, if you have the Maven based application, so you just introduce new version of some technologies, so it might be give the big problem. Maven mostly times give the big problem to the conflicting the jar versions. So that is a very big, might be very big problem. So, and reliability, if you fix a bug, you can introduce a new bug. You can't guarantee it. You fix a bug and you can introduce a lot of bug. So if you're working with the monolithic application that is very big, so reliability is very less in a monolithic application. So we have to take care about our reliability in a big monolithic application. So when to use monolithic application? Suppose if you have less experienced people, you have less fund, and you just want to start your business idea, then you can go with the monolith architecture. So that is, monolith is not bad, but when we have to use, that you should to decide. If you have less experienced people, because less experienced people just create the application and just share that application and create you just create the front end and back end services, and in a single artifact you just deploy and see how your application perform in the market. If your application perform in the market is very good, then you can just break it down and you just create a lot of new components, and you can hire multiple resources, that is expense resources. So you can easily create that application, instead of if you are going to the microservice directly with the less experience, then it gives the big problem. And obviously, if you want to do some POC type of things, you can just go with the monolith. You don't go with the microservice to do any POC type of things, right? So, but right now we are considering like business. Actually, what is the demand of business? If you're comparing the like competitive environment, suppose Magicbricks is very competitive with the 99acre. 99acre is very competitive with the housing.com. Similarly for finance, like Flipkart or Amazon, there's a lot of market and a lot of competitions in the market. So every business want grow fast, innovate fast. So how we can fulfill that requirement as a software? We are the software, we are the architecture, but business guys only want what things want. Business guys want the best performing software. Business to grow faster and innovate faster. Business guys only want a best performing software that grow fast, and business will grow fast. And also as a business guys, I want diversity of devices. Like if you have a business, either Paytm, either Phone Pay or Google Pay. So any lot of app is there. So multiple diversity of devices like iOS. We can see some native based React Native, Angular. So there are a lot of diversity in the technology, a lot of diversity in the platforms. So we have to design that software that is compatible for each devices, because you can't avoid the business that is related to the mobile. If you have the application, then you have to a business app like Android app, iOS app. So your software must fulfill the requirement of each devices. And obviously software delivery faster is very important. Software delivery is faster, very important to innovate faster your business. And handling failure without impacting business less time. That is one of the deployability time challenge. If you have deployability if you want to deploy in a less time, then you have to handle your failures with less time without impacting in our business. Suppose if you have a bug in a particular application, so this bug not be a blocker for your business. You can handle this bug separately, but your business is still going on. So these are actually business demands and hello.
Yes, Dinesh,
Yeah,
we can hear you.
Yeah,
we can hear you.
Okay. So how we can fulfill a business demand? How we can, as a software architecture, what you want? How we can design our application? Which architecture should be best for such type of demands? How we can fulfill these demands? So we need a application architecture that actually enable rapid and frequent deployment and reliable deployment with a less testing effort. And also it will be simple to test, maintain, and scalable. some meeting. You just. So it's time to move to the microservice based architecture. If you want such type of application architecture, so we can use microservice based architecture. It might be fulfill your requirement, right? So microservice, first of all, microservice architecture is just like a good practice how we can create your application to make these things very easily, like rapid deployment, frequent deployment, reliable, and maintainability. Whatever ability we have discussed, maintainability, testability, reliability, deployability, whatever scalability. So these feature must be provided. So we can choose the microservice architecture. So microservice, one of the things, like microservice is not a well-proved software architecture. Microservice architecture is based on the how we can design our application. If microservice we are not designing properly, that might be go to hell. So it on that time you might be prefer the monolithic application. So we have to take care about. So in single word, microservice is not a silver bullet to use. You have, it's based on the how we can design our application, how we can select the component wise components, how we can interact with a lot of things. We have to take care about that. But microservice, if you design the microservice based application very better manner, so it might be give the all benefits whatever business want. So microservice, microservice simple patterns, like we just whatever module in a monolith application, we just uh, packed in a single artifact. Here we just create the lot of application, like based on the modules, and self-contained modules, and loosely coupled, and these application deployable independently. We can deploy in a machine, right? These are microservice patterns. So we just simple word, we have the application, we just break down that application and deploy separately, right? So if same application we have discussed with the monolithic, if you want to design that same application in the microservice, how this architecture look like. So we have designed the, I can do 3-4 component: account service, and inventory service, and like book service, order service, and shipping service. So on the particular monolithic, we have designed these 4 components in a single unit and deployed. And also we have the UI part in a single part. So, but here we have create different application, like account services, different application, book service, a different application, order service, a different application, shipping, different application. Even they have private database as well. We are not sharing database. On a monolithic, we have the shared database. We have used one single database for all component. But here, there are no rule to use shared. We can use, we cannot use. It's depend upon the business scenarios. We will discuss these things, how we can use shared, when we can use not. When we so not we use shared, when we can use shared in a NT patterns, right? So account service use the account DB, book service used inventory DB, order service used order DB, and shipping use shipping DB. So one of the things, like where is our front UI? We have that separate UI application. We are not involving that UI part in a service-based application in the backend services. We have designed a UI application separately. We can use either technology, Angular, React, or any front-end technology you want to use. You just create single artifact for the UI only. And if you have the mobile app, we have created a lot of mobile app. We can use that mobile app, and we can we can use mobile app and to communicate to the services. We can use API gateway to REST service. So we will discuss more about the API gateways. So such type of architecture will be, if you are designing the same books online bookshop with the microservice, then such type of architecture will be there. So when you provided the microservice architecture, maintainability is easy to maintain. Why is easy to maintain? Because we have single artifact for single module. So each module very simple and very small. We can test. We have discussed in the monolithic application, when it is a small wall, then easy to maintain. In the same things for microservice. If any application is a small wall, then it's still maintainability is very high. We can maintainability is very low. We can just easy to maintain that application. Scalability is a very easily scalable, because each application have separate container to run. We individually we can scale the particular component. If we want to invest some resources over the account service, we can just increase the number of servers for the account only, if account service generated the business more. So we can scale component wise here. We can't give the resource that particular idle type of application, like some of the applications like feedback application or review application is not generating too much of business. Just we have these business only for our audit. We can just audit our business. That's why we have the review or feedback. So you don't invest much on the feedback or review. So we have to invest on like a like cart system, where we make the PGI payment gateway when we are going to payment. So on that particular things, we have to invest a lot of resources for that. So we can easily scale a components, right? Testability, we can say easy to test, but it is not too much true for the microservice architecture. So easy to test, if you want talking about the some particular microservice, that it is easy to test. We just if we are talking about unit testing, then it is the easy to test. Whenever we're talking about the integration, they're difficult to test. So we will discuss how we can in the testing of microservice. Deployability, is a small ball, and it's not dependency to other technologies, or so it's independent deployment. So we can just small application just deploy. We can easily deploy an application. We don't need to be wait for downtime. We can easily deploy, because there are a lot of service running in different machines. We just run the particular component in a particular machine. It's independent, so you don't need to be down that application. So independent deployment, that's why business don't have downtime for any type of deployments. We can easily deploy and frequent deploy. Reliability, it's because microservice provide a fault isolation, because in fault isolation, because we have some buggy system, some buggy build. But if you, in a case of monolithic, if you release a buggy build, that impact your whole business. But in a case of microservice, suppose in one of the developer left a lot of bugs in a particular component. So due to that component, that not might be you just shut down your whole business. All service, other service will be run, right? But the particular service will be, might be down for a particular time. But we can also handle this fault isolation by using some of the technology like Netflix histories. So we will see how we can use that type of things to handle fault tolerance. So reliability, improve the fault isolation. So that's reliability is very much for it's very good for microservice architecture. Loosely coupled, each component deployable independently. So it's loosely coupled, so there's no dependency between the components. So it's we can independently deploy, we can independently scale. So that's a loosely coupled. And technology diversity means we can generate service. We are not focusing. Just suppose there is a monolithic application. If you want to design a new component in a monolithic, so you have to use same technology whatever we have used earlier for the particular component. Like we can't migrate like Spring Boot 1 to Spring Boot 2. Yeah, we can say if we are creating the application in the Spring, we can't make decision in quickly to move to the Spring Boot. So that's a very difficult decision. So technology diversity here is very good. So we can just choose any technology, any version of the technologies based on the components, because the loosely coupled, so the technology will not affect to the another component. And also it's developed by a small team, because microservice is a very small part, so it easily developed by a small team. So you don't need to create a big team for a microservice. You just, and you can also handle by individual contributor as well. But along with the benefits, it's have a lot of drawback. So complexity, obviously, if we have the multiple component, multiple application, multiple services, multiple technologies, multiple diversities, so these multiple things create the complexity as well. The complexity in not in sense of code level, complexity in sense of communication between the teams. Suppose a particular company created one payment service, another company create, another team on same company created an order service, another team created the inventory services. If you have any bug in particular service, and unfortunately product team assigned to the inventory team, bug to the order team, so it's like Mahabharat, why you are assigning to me? It's going to that particular team. So that some type of things very difficult. So coordination across the team is something very difficult. Complexity increased here. So complexity is a very big concern here if you are working with the microservice architecture. So you need a coordination across the team. One of the member that would handle as a take the ownership as a whole product, because business, either you are creating microservice, either creating monolithic, business only want input and output. They don't want a particular service or particular. So business guys only log a bug to the technology team, but he not know which service is responsible for this bug. So such type of coordination we have to required. So one of the experienced guys required for such type of coordination, handle these things across the team. And difficult to achieve consistency across the services and transactions. So because services are deployed independently in different servers, so there are something problems for the database consistency and transaction management. So it's a very difficult. In case of monolithic, you just use the either a transactional, and you can just you can easily achieve the transaction management. But in case of microservice, that is very difficult to achieve, because as I told you, business means input and output. Whatever services is involved in this particular period, business don't care about that. So if any failure in any service, it should be rolled back. So the tracking, service consistency and transaction management is one of the big challenges in the microservice architecture. Obviously harder to debug. If any bugs comes in a system, so you need to
is it okay to ask a question now or later on?
Yeah, you can ask here.
Okay, so I'm a bit concerned about the transaction in the third line. For example, we have a service service layer in a small microservices, and where there is more than 4 or 5 tables need to be updated. So using the transaction or annotation of the transactions, can we achieve that in the microservices, or is it not possible?
No, it's achievable, but it's difficult to achieve actually. So whatever, if you talk about in a case of a single monolithic application, so it's just at the service layer, you just use the transaction annotation and define your propagation strategy. So according to the propagation strategy, you can achieve that transaction management across the tables, across the services. But here, what is the challenge? Here, our application deployed in a different server, not in a single application. So if you want to achieve this transaction management, so you have to use some patterns like some Registration defines the saga patterns. So we have to use like eventual consistency, CQRS. So there are a lot of patterns we have to use.
Or we can go back to the 15-year-old transactions system. Like if there is any exception or error occurred while doing one, then roll back others.
Yeah, that's
something
like two-phase commit. One of the
two-phase commit. Yeah.
one of the
Yeah.
example. So such type of things we have to use. So in case of data transaction, that might be difficult to handle. So that is not sense ki we can't, we have to do, because you know, if Flipkart actually deployed multiple services, imagine hundreds of service for a services. So if any payments failure, so they will any order cancelled or failure, so any error comes, so they will roll back all things. So they are handling such of things very easily. So but we have to involve, we have to design some architecture for that as well.
So, so just to summarize this, what I understand, let's say I have a WAR file, an artifact as a service, which is deployed on a box one, where the database is also there on the box one. There's 4 table need to update it. Now I'm writing a service layer, a function, where 4 table need to be updated from the same on the same box on the same database. So using microservices, I mean, I think we can achieve. Yeah, and following the same Spring Boot principle, like using annotations, or will that work or not?
So actually, what happens if you are achieving these things in a single application, so it's very easily achievable. But what once suppose it is a breaking in the different application, and we are actually working as a single trace. So we are what is the task? Actually, task is a single work of unit. So that work of unit might be involve lot of services between them. So
okay, I got an answer. No problem.
Okay.
please carry on.
Okay, thank you. So harder to debug and trace distributed nature, because you know, our application in distributed nature is deployable in different machines. So it is sometimes it's very difficult to debug a issue. Like we have to use as logging system that will be traceable. So one of the example like ELK, or like we will discuss Kivana, I all introduced to solve these problems, like Sleuth, Jipkin. So the technology we can use these for to handle these things. So a lot of things is there to handle such type of complexity, but even these are complexities there. So it is not too like debugging in a monolithic application very easily. We just debug the application in a single unit, so we just easily traceable. But in case of distribution, so that might be difficult. So integration testing, as I told you, it's a sometimes required great effort to test end-to-end testing, because communication between the services, it's difficult to test for integration testing. So integration testing is required some extra effort. In case of JUnit, so it's not required too much effort, because JUnit working in the single class or single method, so and in a single microservice, so that is very easily to test. But in case of integration, that might be take time. So when to use microservices? So whenever if you have a lot of money to spend, you have the experienced guy, like you have the experienced developers, so and you want a project, you have the idea that which you want to need to deploy in your market. So then in case of new project you want to develop, so you can go ahead with directly go with the microservice architecture. And in case of you want to create like a business in a module wise, like you just creating business by separating with separating concerns in the business applications. Like we want to create a module like modularized application, like one module should be deployed different, like admin module should be deployed, print module should be different, and account inventory management should be different. So such type of things we can choose microservice architecture if you want to divide our application into different modules. And cloud native applications that like if you have cloud native, 12 factor of cloud native application, there are a lot of, I not remember right now. So if you want to create the application that's support that 12 factors of application, like diversity of the devices, or there are a lot of factors is there if you can search on the net. So if you want to create a cloud native application, in such application that is perfectly perform all 12 factors, then you need to be switch on microservice architecture. Quick deployment, quick development, and independent service delivery, because you are creating a small service and we just quickly we can develop, and it will not take much time. So agile methodology very suitable for microservice architecture, because we just two week of sprint we can just create the service and deploy and release to the production. Efficient modules means efficient in modules means like if we want to create some modules very efficient, like some of the, because we have the business and some of the module very efficient for your business. So in that case we have to go with the microservice based, because efficient module means in future we have to scale that particular module. So we can easily scale that particular module if you are using microservice architecture. And alongside fast growing product and team, because we can easily develop, we can easy quick development, quick in deployment, so it's very fast and growing the product for. So let's go ahead the microservices in detail, just go through high level overview of SOA. So actually is before the microservice, one lot of company has used the SOA based architecture. So it is something if you can compare with that SOA with the microservice, so sometimes it's a matching, but ultimately it's a different architecture. So SOA actually is also part, like we are creating services according to the module, and these we deploy these services separately. But in case of here, whatever, it's depend on the vendor protocol to communicate the if you want to communicate these services, we need a third party protocol to access these services, and these services actually using a single database. So what is things like if you see the same application in SOA, so we have created 4 services and we communicate these services through the one ESB, enterprise service bus. So if for each client we need to, in each client, like consumer layer, everything is a client in the consumer layer, and provider layer everything is the services, and between them is ESB. So ESB is just a communication channel to provide the service to the consumer layer, and these services using the shared database system. So these are service oriented architecture. We are creating the services and backend services. We are separating our UI or consumer layers from the provider layers. So consumer layer, it's like who consuming the services through the using ESB, and provider layer like providing a service to the consumer layer via ESB. So ESB just provide the communication methodology. It's a protocol, like just protocol and a communication bus. So it's a like you can see that is big picture of services architecture, like software architecture. So monolithic just single unit. SOA just coarse grain, like we have services but not small. But in case of microservice, there's a fine grain. So we just divide much more services. We are deciding how we can decompose more to provide the loose coupling, more loose coupling. So that's a high level comparison between them. So now challenge is that I told you application decomposition. How we can decide how we can decompose our application. So there are no hard and fast rule to decompose our application. So it's a depend upon the how we can and how easily we can understand your business. We can easily decompose our application as much easily we can understand your business. It's totally depend upon the business. If you don't much aware about business, you can't decompose your application. So before going to the decomposition of application, in the microservice-based architecture, you need to understand your business first. What business want? So business guys is only told like what they want. Like this is the input we want going to the like. Suppose if you want working with the real estate website, so they want like we have the some property portal, we just registered users and you can post the property, we have the search, and so after search we can contact details and detail page, and we just post your requirement or contact to the particular person, this type of business. And now we have to understand component wise, domain wise knowledge, like how that real estate domain works. So according to this, we can decompose our application. So might be decomposition, might be first time decomposition might not be like 50% correct. Second time we can move to the 60%, then 30%, and like 70%. So decomposition not happens in a single time. Decomposition will take some time of your application. So we can see how we can see decompose our application. So it's just a big challenge, microservice of architecture, to break the application into existing application like monolithic into several services. So that is question, challenge, how to decompose an application into services. Here I'm not talking about the microservices, services only. First of all, we have to decide how we can decompose that particular application to services. How we can generate a component that provide a business service, one entity that provide a business goal. So service examples a business capability. It's end-to-end business capability. It provides some interfaces to the public. A service is just like a public interface to provide some business input and output. So it's based on the business capabilities. So it's a capabilities of businesses, and it like it. If you're talking about the business service, so what things we can perform over the services? We can give the command to the service, or we can query to the service, or we can raise the event to. Suppose in application, what we can do? Either we can post property, either we can search the property, or we just generate an event, or we subscribe an event. Like suppose if any property posted, please notify to me. We just subscribe the event. So these are things provided by services. So these are services actually. If you're talking about the structure of services, so service just provide a business entity, a business goal, and each service has the private database. But in case of SOA, each service using the shared database. But in case of service only, when we are going to divide our application, so we have to consider what is the service high level. Search service, we just if you want to create the search result page, so we just define a search service. So search service just taking data from somewhere and render the data in front of UI. So search service, what events we can just like from where we are getting, from where we are querying the database. And one of the post service, anybody comes to the post service and post the property, just create the inventory and post. That's like command. When we're talking about the post and we are updating and we are doing something, like we are impacting our database, like we are doing the commands, we are deleting, either we are updating or inserting commands. So, and querying, just like we just want some data, just you can just send your query to the services, render the data to the API client. So we can query or commands through the two communication channel, either synchronous or asynchronous. So synchronous, we obviously know REST services, very popular technologies, very popular, one of the very popular strategies patterns to use REST in case of synchronous. Asynchronous, messaging tools like Kafka, one of the tools we will see an example how we can use Kafka whenever we are creating an event. So API client actually just one of the inbound, outbound, you I think heard about hexagonal architecture of Java. So in some inbound service, some outbound service. So inbound service just like commands and queries, and outbound just like API client. So API client just exposing the public operations. How we can access this service is publicly. So public operations depend upon the how much public operation is exposed by the particular service. So event subscriber and event publisher, just event publisher, one of the things like we just from the different service or from the different channel, we just publish a event to the service, and that if any client subscribe that particular event, it notify to the particular. Let's suppose I'm user, just click on the one of the checkbox, please notify. You heard about some the, I think whenever we are going to purchase some product, so if product is not available, just one of the button is that notify me. So that's just one. Yeah. So just click on the notify me, just you subscribe that event. And whenever that product is available, then when that product is available means event is published. And that event actually all sent through that notification to all subscriber. So that is event-based communication. One of the synchronous communication, asynchronous, that is event-based communications. So that is actually structure of service. That is not means it is a microservice. It is a structure of service. First, we have to design our service, then going to the microservice. So how we can design a service? That is a particular structure. Or what a particular service perform that operation, either inbound or outbound. So we can say service is a microservice. So we can say service is a microservice or not, or can't we say? So you can see service and micro. So it's depend on the what public operations we are introducing. Suppose that particular service introducing 2 or 3 public operations, and also it is depend upon the business. How much public operation should be performed and how much public operation should not be performed by a service. It's also depend upon the business. If you consider a particular service perform 2 or 3 business public operations, that you can consider the service as a microservice. So if a service perform a micro business public operations, a service perform a micro public operations, then we can say that particular service is a microservice. If a service perform lot of public operations, if this particular service perform lot of public operations, then we can't say this is a microservice. We can say this is a distributed monolith, because it has the business capability into end. But we can't say this is the microservice. I think it's clear for all. If anything confusion or not able to understand, just raise your hand. I will come to you.
See, it's me again, Dinesh. Sorry, this service. if there is further sub-service in the artifact or in the application, so then only we can say this is microservices.
Could you repeat, please? Could you repeat, please?
For example, can you hear me? Okay.
Yeah, I'm hearing you.
Okay, so for example, let's say we have created a service and registered with the discovery application. In that service, there has to be more than one sub-services. Then only we can consider that this is a microservices application.
Yeah, actually, microservice is one of the not hard. There are no hard and fast rule to we can say this particular service is microservice. It's depend upon the architecture who design the application. Suppose the particular service perform for me, suppose it performs 10 public operations. So I'm okay with that. It's a microservice. But for you, it's perform 10 operations is too high. You just threshold is 5. If that particular service perform 5 operations, then it will be microservice. Otherwise, it's monolithic, distributed monolithic. So for you have to decompose again based on the business domain or subdomain.
Yeah, I got it. I got your point. So again, and there was one more thing you said, the event processing. For example, I'm looking for a property and I couldn't find a property, and there is a checkbox there in under below say notify me. So in that case, what happened internally, my detail get stored in the database, and if there is something comes up with that matching, I will be notified through email, and that
Right.
this entire process will be taken care by Spring Boot or any batch job.
Yeah.
Or
So it's actually depend upon the because there should be some backend service should be run continuously, like Kafka. We can say a Kafka consumer is there. We just push any property or any book, any inventory, post it to your system. So from there, a Kafka consumer push that entity to the Kafka server, and there are a lot of subscriber of Kafka producer. So just consumer and producer just producers have produced the event and push to the Kafka, and consumer like us, we are we are subscriber, we are consumers. So one of the consumer running continuously and check that particular DB, such type of things as coming or not. If coming, then notify me.
example, I'm sorry again, I'm stopping you. Apology for that. For example, we have say for example, I'm working on a small organization where this kind of scenario comes up. So less resources. Instead of Kafka, can we use a Spring Boot job and schedule it on every an hour or half an hour? Can we achieve this
Spring
through
Boot job? Different
batch
things.
job? Sorry.
Kafka differencing. Kafka is like a
No,
messaging queue.
Yeah, I understand. Kafka is a completely different thing.
So
in
job,
the scenario we talk about,
yeah.
For notification of similar property if comes in future, can we achieve this entire
Obviously.
functionality through the Spring Boot?
Obviously. So what happens
job,
if you are using messaging queue that like a real time? But if you want to achieve like you want lagging between them, suppose if you just notify me, you just click on it, and suppose within second one property posted or one inventory posted. So if you are using Kafka, then it notify in real time.
Okay.
Some lagging of time. But in case of a batch job, it might be run some duration like 15 minutes, after 15 minutes, 10 minutes. So after 10 minutes, it will be notified to you. So alert based system, whatever we are getting notifications or alerts, these are one of the things based on the whatever you are talking about.
Yeah, got your answer. Okay, thank you. Thanks.
So that slide is, I think, okay. Yes.
Can I ask? I'd like to know, like we are going to decompose our application, right?
Right.
So some of the services, can you hear me?
Yeah, I'm hearing you. Yeah.
Yes, sir. Now when we are going to decompose, some which may have sharing the data across the application. Let me give you an example. Now we may have some user information, right? Even that logged in user information, we need to share across the other microservices as well, right? That kind of component, how we are going to decompose, how we are going to integrate data. I'm going to integrate data across microservices, how data, and we have going to invoke other HTML from, not for example, say I have user service. Basically it's going to contain login function.
Voice is breaking.
Your voice, yeah. I'm not able to hear it properly actually. Your voice is breaking somewhere.
Hey, your voice is echoing actually. You are not audible here. Are you using any mic or something?
Yeah, 1 second, let me take it. Sorry.
Yeah, please, yeah.
Either you can write your question, so I will come to you back. You after just finishing the event, I will give your answer, right? So whatever I understand is you talking about some, like if you want to have some logging system, you want to log in the user, and how we can maintain that logging across the application, right? Hello. Your voice is not coming. Sorry. So you can just write your question. I will come to you, right? So let's go ahead. Right. So now. I have recording for you, so you can, if you're not able to audible or I'm not audible or you can not able to understand much of things, so I will share all audio and videos with you after completing this event.
Fine.
Okay, so application decomposition. Yeah, so here till now we have discussed about the service. So now we are going to discuss some more in one business related terms, that is actually not business, we can say it's directly related to a business, but in case of technologies. So whenever we are going to decompose our application, we need to define some bounded context. So what is a bounded context? So bounded context, a bounded context is based on the business capability in a particular bounded context. If you are using a term that have business meaning for that under this bounded context, if same term we are using outer bounded context, that particular term might be have same different business meaning. Suppose uh, if you have like Flipkart or Amazon or any e-commerce website, you can see account number. So in case of Flipkart, account number you just might be customer ID, right? Might be a customer ID. You are talking about the account number, it just means customer ID. But in case of different business, like in case of same in the in the case of like in the Flipkart, same like payment gateway or payment related module, you can see, you can ask account number, you directly focus on the bank account number. That means account number in a particular module is the something different meaning, and different module is something different meaning. So bounded context should be defined. That means we have to use a bounded context whenever we are designing the application. So it should be a strict bounded concept. So if you are creating a strict bounded context, that would be a good monolith, but you can't say it is a microservice still, because it is a service. As here it is very, if you are designing the service, that is very well bounded context, but strict is eventually it might be a service, but not always. It would be a good monolith. That means if any chance to decompose more, so we can consider to decompose more, it might be a further microservice. But it can't say कि a bounded context could not be a microservice. It could be a microservice. But each bounded concept not a microservice. So microservice just about depend upon the how much public operation we are going to expose. That is only about the microservice. So as I told you, bounded context is not always microservice, but a microservice is a bounded context, but vice versa is not true. Strictly business application, strict business applicability context, just bounded about the bounded context. That's like what is term mean, or like whatever things I told you. So whatever boundary over that bounded context, known as context boundary. So this boundary known as context boundary. So we have to define our context boundary when we are trying to decompose our application in such way that we had achieving the good microservice architecture. We have to focus on the context boundary. If we focus on the context boundary very well, so code duplicity of the code is very minimal. If you are not focused on the context boundary, that might be one business functionality might be same application, same business functionality might be in service A, same business functionality might be business B, same functionality might be business C type of. So that means we are code scattering, like we are not going to achieve that microservice. Ultimately we are moving to the monolithic hell. So we have to define the context boundary very well, so it minimizes the duplicity of the code in a multiple services. So we can decompose our application based on the business capability or domain or subdomains. So business capability, is the actually it's a very high level of business rules. Actually, whenever we are define the business capabilities, ultimately like we are achieving a service. So account service, one of the business capability, like we are management of customer management system, or we can say inventory management system is one of the business capabilities. Inventory total, one of the business capabilities. Who's managing the business capabilities? Or account customer management, one of the business capabilities. So payment system is one of the order management, one of the business capabilities. So business capabilities actually is based on the business, and each business capability deliver a business, but each microservice can't deliver a business and can be deliver a business. If a microservice based on the bounded context is a service, then it's a deliver a business. But a microservice is a perform a very less public operation, so we can't say it's a deliver a business. So it's a high level customer management, order management, and book inventory management, shipping management. These are business capabilities. These are recognized business capabilities, and each business capabilities has inside on business context boundary or bounded context. So according to that, if you want to create the architecture, so we can create customer account management system for account service, order service, book service, or shipping service. Accordingly, we can generate these services, right? And obviously, if you are suppose customer account management is very big service that that actually expose the several public operations, so it need to be considered decompose again to avoid distributed monolithic hell. So accordingly, we have to split a domain into subdomains. So domain subdomains is things actually whenever we are talking about domain driven design, then we can consider these things subdomain domains, where we are designing an application based on the domain. Mostly SUA is based on the domain, but microservice actually might be on the domain, but it might be on the subdomain. It depends upon the how much a small public operation you want, right? So simple example, we domain just customer account management, we suggest create a subdomains for that particular. So we can accordingly we can design our service. So either we can design our service through the business capability or domain based. So both don't have any drawback or don't have any written drawback or written benefits. It's totally depend upon your architecture, your business, how your business going to grow in a future. So it's depend. So continuously we have to focus on that system. So that doesn't mean suppose initially we have created an application based on the monolith, based on the microservice. So we are for a customer account management, we are creating the account service. So it doesn't rule key like everything whatever related to the customer, we will create a same inside the same application. If any business capability different from the account, but it's related to the account, but it might be different, so we can just create different microservice for that. So it's called subdomain based. Suppose if you want to handle customer review separately, so you don't need to be implement that logic in the customer account management. You just create your different service that only provide the particular customer. You just give the customer ID and provide the review of particular customer. Same for order, same for payment. So that's based on the subdomains. Oh. Okay. So handling the cross-cutting concern. So here I'm not talking about the EOP first of all. So Spring EOP is also about the cross-cutting concern. Here I'm some challenges that is related to the Spring. Microservices. So how we can using some microservice chases framework like Spring Boot. So first of all, handling cross-cutting concern. What type of cross-cutting concern might we faces whenever we are talking about the microservice architecture? So like metrics, externalized configurations, distributed tracing, health check, logging. These are not related to your business, but it might be, these are very important for your microservice. How we can handle, because external configuration, why we are picking an external configuration here, because a microservice have multiple instance, or same configuration we can use in a different microservices. And distributed tracings, we have performed a task, and each task involve multiple microservices, and each service might be generate different log. So how we can trace these log as a single unit of work? So distributed tracing and similar logging, how we can handle log for a, because as a unit of, as a business, we have to aggregate these log in a single application. So we have to use some of the technologies that perform the logging aggregator. So health check, we can, how we can check the each service is running fine or not. So these are cross-cutting concern, how we can handle. So in that particular slides, we are not going to in detail each of topics, because each of topics is a very big one of them. But still, I will just say we can easily achieve these whatever things we are in a blue box. We can easily achieve by these technologies, Spring Boot and Spring Cloud. So one of the my favorite technologies to create the microservice by using Spring Cloud and Spring Boot. So mostly all of things we can achieve easily. We can configure easily. Spring we can externalize our configuration by using Spring Cloud config. So each one of them things, mostly we can use actuator to health check metrics along. So Spring Boot provide the actuator, so we can configure our actuator. We can create our own metrics by using actuator. So Spring Boot and Spring Cloud mostly provide 90 or 80 to 90% things we can handle through Spring Boot and Spring Cloud. And like logging, we can use log4j, logback to handle, and we can use ELK to aggregate these log in a single server. Kibana we can use for that to see to aggregate these logs. Health check we can actuator we can also use for metrics. Distributed tracing handled with ELK in Zipkin, and Sleuth, one of the technology to use tracing, how we can trace a particular log for a particular task. So these things we can use for handling the cross-cutting concern. So I will come to these topics in very detail with the example. I have example for each of topics. So we can see how we can run ELK, how we can run Zipkin, how we can run Sleuth to trace the logging, how we can configure the externalized configurations, logging, and everything we will see. So till now we have discussed handling cross-cutting concern. So I think it's time to take a break, right? So we will continue after 10 to 20 minutes. After 15 minutes, we will see here, right?
Yeah, fine.
Yeah,
so
that makes sense. Thank you. Thanks for the break.
Okay. Okay, guys, let's meet after 15 minutes. You can leave or you can stay here. Just make yourself and mute.
Okay.
Hello. Could we start now?
Yeah, Dinesh. Yeah, please start. Let us ask two other members.
One of the member I think left.
Sorry.
One of the member. There are 9 total. There are 9 members right now.
Okay.
Okay, let's resume our session.
Yeah.
I think we can start, Dinesh.
Yeah. So till now we have discussed some how we can create our application based on the microservice architecture, and we have discussed some decomposition concept, how we can decompose these applications, and we have compared different software architecture patterns. So cross-cutting concern, we have discussed how we can handle the cross-cutting concerns. So cross-cutting concerns might be lot of there. So might be your security, one of the cross-cutting concerns, how we can handle security across the microservices. So we will discuss these things, security patterns. We will have plan to lot of such type of events. We will discuss in details each topics. So we will see end to end how we can authenticate our services to use Spring security in Auth2. So we will see talking with the authentication mechanism. So these are part of different events. So right now we are moving to suppose we have decomposed our application, we have handled cross-cutting concern. Now how we can deploy our application, how we can deploy our services, which pattern should we follow to deploy our application. So we have several resources to deploy our applications. So, microservice concept is not too new, it's old concept. So on that time the microservice concepts not successful because it was not successful because on that time the resource was very costly, was very expensive to if you want to purchase the machine. So it was like if you want to purchase the software server as a iron port, so it's a lot of money to invest, and you have to take care about that hardware in your home, and you have to take a room that is AC room, or like a lot of things to be required to handle the server. So on that time microservice concept not too successful. But right now this is the virtual there are a lot of virtualization over the hardware. So BM concept is there, microservice uh, container based technology is there. So the hardware is not too costly right now. Right now software must be performed better. How much cost involved to the hardware, then nothing, the no one uh, consider. So so in that patterns we will see how we can deploy our microservices and which one of the pattern we can use to deploy the microservices. And let's move. So right now we have the lot of services, how we can deploy these services. Let's see. So if we are talking about the deployment patterns, so deploy each service set of instances. Like we can deploy our services. Either we can deploy a service a single instance, or if you want high availability or high throughput, then we need to improve this instance, like number of instances of particular service. Suppose account service or payment service is very crucial service for you, for your business. How we can scale, how we can achieve the high availability, high throughput. So we uh, have to improve, we have to increase the number of instances for particular service. How we can handle these services, how we can handle the deployment patterns. So see, throughput and availability, I think the terminology much aware about everyone, right? If you're not able to if you're not able to get any terminology, you can just ask.
Maybe in a line you can talk about this throughput.
So throughput, just like how much data we can process in which time.
Okay.
Just about. So like we required a lot of like number of request, number of handle, how many number of billions of requests we can handle in a second. That's about the throughput.
Okay, like it's threshold, request payload threshold.
Right. Not threshold, we can say ki, threshold just a limit, but throughput just like how we can easily handle these requests without taking a lot of time. and we
Okay.
generating the output as per as requirement. So throughput, such like of things. So we just responsive. We can see one of the term like it's responsive system. Should we just go and response?
So throughput can be partially as per my understanding, throughput can be partially depend on the like its number of OS thread and the
Yeah, whatever you are talking about is throughput. It's like you are moving to the too much to in vertical level scalability. So here I am just horizontally I am talking about on the horizontal level throughput in a horizontal level scalable and throughput in vertically scalable have different meaning, but sorry, different wording, but meaning is same.
Okay.
Whatever you're talking about is a vertically. So if you are talking about the same machine and we are talking about the thread or software like operating system, on that term is different, but meaning, high level meaning is the same.
Okay.
So we have used a deployment pattern like we follow these patterns like a multiple instance of microservice per host. What it does means, we have services, like we have services, service A, service B, service C, service D. So we have several services in our application. We can deploy these services like service instance of service A, instance of service B, instance of service C, deploy in a single machine. And instance of service, second instance of service A, second instance of service B, second instance of service C, we can deploy different machine. That means in a single machine, we are deploying multiple instance of multiple services, right? So
Right.
we will define too much like in a further slide. So in single instance per microservice per host, it means a single instance of OP microservice we have to deploy in a single machine. If you have the different instance of a same machine, same microservice, we have to take different machine. That means one particular machine used by the one single instance of a single microservice. So in that concept, there are two parts. We can use VM based or we can use container based. Right? We will discuss. Let's see. So multiple instances of microservice per host means we have as I told you, instance of account service, instance one of account service, instance one of order service, instance one of book service in a single machine, that is host A. We have deployed 3 instances in a single machine. Similarly, you can say parallel different instance in B. That means a particular machine have several build, we can say in one word, like a lot of war files we have deployed in a single machine. So but it has some benefits and it has some drawback. Benefits like with the resource utilization, very efficient resource utilization means whatever hardware we are consuming, what is so resources with these machines we are using very efficiently. It means there are no that might be the number of processor or number of, suppose if 20 core processor machine we are using and we have only one thread to be run. So that means other 20 or 23 threads processor is like core is like wasting. We are wasting your money. So that means how much have resource we have to deploy, how much of builds on that. So resource utilizations is something very much utilized here if you are using multiple instance of a microservice per host. And deploying a service instance is relatively faster, because if we are using single machine, so they are not too much of server we have to handle. So there are there's few hard software and few hardware we have to handle. So relatively it is faster to deploy if you are comparing with the single single instance of microservice per host. But it has some drawback as well. So what type of drawback? As you know, the isolation, there are no isolation between the build. There are no isolation between the instances, because if server is down, so all instance of deployed in the same machine is down. There are no isolation So it create conflict over the resource. Might be if load is increased, so might be resource not available for a particular, like memory might be problem. So it might be create some problem over the utilization. So that is the drawback. So we can't increase the resource as per capability of particular instance of services. So that means we have a lot of service in a single machine. So if you want to introduce a new resource, that would be used equally by other services as well, even the service is idle. So we can't increase a specific resource for a specific instance of a specific microservice. So that is one of the drawback. And it is also difficult to monitor resource utilization, and because you can't check which service are using which, how much number of memory, or so that is something difficult to manage. So it's moving to head. If you are want more benefits, then you can go the single instance of a microservice per host. Obviously in this part you can say there are 6 hosts: host A, B, C, D, E, F. So each host has single instance of a single service. Host A and B have two instances of microservice account service. Host C and D have 2 instances of same service order service. Similarly, E and F have book service instance 1 and instance 2. So here you can see each machine have single application. So obviously drawback will be like resource might be free. So cost might be more than this approach. Here the cost less effective because there are 2 machines only used by this 6 instance. But here you can see 6 machines we have to use to handle.
Dinesh, I have a question here. Which one is preferable? What is advisable? Each instance per host, or couple of instance, one host?
So advisable is that it depend how it's depend. Suppose your services, you have 6 number of services, and out of 6 services, 2 services very less used, just you good to have. So you can deploy these 2 services in a single machine, and baki 4 services you have to deploy in a different instance. On that time you can easily scale the services, and you can increase the number of resources to increase horizontally. So if your service is very crucial for your business, so it is advisable to use single host for a single service.
Okay.
Sorry to interrupt. There is one more workaround as per my understanding. Like if we have some services and that can be shared among different our clients. And suppose as per the resource utilization, irrespective of their idle time. So what we can do, we can have a SOAP simulator, and that SOAP simulator we can write some different port numbers. On that port numbers, we can put some multiple instances of the same application. So on the same time we can check how many request get by that our server, and how many requests processed per second. So that can be done when we are talking about the resource utilization.
Okay.
Sounds good. Yeah.
So thanks, Gyanendra. Someone is. So now move to the same part, how we can use VM, how we can use container. So it's one of the very big topic, how we can create the VM images. It's related to something DevOps related things. So before that we have to see the benefits for that. So that's if you are deploying instance per host, so obviously it's a complete isolation between the instances. Easily we can correct defective piece without affecting others, and no resource conflict. We can a single service using single resource. So that means there are no conflict between the resource utilization. There are no deadlock. There are no memory leak. There are no memory problem. So it might be solved. So we can accordingly we can increase efficient module. business demand. They are one business demand efficient model. So we can increase resource capacity to a microservice instance on demand. Easily monitor, manage, and redeployable each service, because there are no, if you can restart a server, restart a machine, so there are no impact to the other instance of different microservices. So it's easily deployable, redeployable. So some drawbacks very like less efficient resource utilizing, cost matter, because if you are increasing the resource, it means we are increasing the cost behind that. So management of resource is sometimes difficult, because we have to have a separate DevOps team to be monitor each server of the application, because if you are deploying lot of server, lot of things, lot of IPs there, a lot of machines there, so we have a separate DevOps team should we manage these resources dedicatedly. So there's many more drawback might be there related to the number of resources increasing. So single instance, same things, single instance per host, but host is VM right now. So host might be VM, host might be container like Docker. So here I'm using like if you are using VM based technology, such we can use account service on VM, separate VM. So VM, nothing is like virtualization over the hardware. You know, there are cloud system right now is there, so everyone moved to the cloud like AWS, and we are using platform as a service. So we can take EC2 instance. That is one of the AWS microservice, AWS VM. So we can choose VM, and we just deploy our service as a VM in the particular instance. Similarly for container over whatever, suppose VM is the virtualization over hardware. We just single hardware, we just create separate VM. We just generating lot of VM in a single hardware. And container is just like virtualization over software. It might be like in the single VM we can virtualize different container. In a single VM we have multiple container, and each container is very isolated and work like individually, and each container have own resource utilization within the boundary of container, so called container image. So you know, Docker, if you want to use Docker, so we have to create Docker image and deploy this application as a Docker isolated image, and this Docker image very we can it's a platform independent. We can easily deploy this particular image in any hardware. So it's actually taking that particular software virtualization over the software actually. So using same software, but internally container has own operating system, on everything's on inside the image. So we will discuss these things when we will plan for discussion for Docker and container, Kubernetes, all other things. So we will just see how we can create microservice Docker image and how we can deploy in the Docker. We will discuss these things, everything. So these are patterns actually how we can deploy. So it's a very obviously depend upon your requirement. We can choose one of the deployment patterns. So I would prefer, if your service is very crucial for your business, so you can choose single instance of microservice per host. If your service is not too crucial, it's a very good to have in your business. So you can go ahead with the per host or multiple instance per host. It's depend upon your it's also actually if you are not deploying crucial in suppose you are deploying less usable microservice in multiple hosts, so you are investing a lot of hardware, a lot of money in a such service that is not generating business. So it's a good decision to deploy same less usable microservice in a single machine, right? So and container, container actually is not too mature right now. So most of company is actually looking for container based technologies, and some of the company still believe on the VM based technology. So some of the company still from where I'm working till now in my this year of experience. So I'm still using BM right now. So most of companies moving to the container based, because Docker and container right now going to mature. So it's actually less cost effective. So it provides a lot of benefits, different benefits over the BM. So after deployment patterns, let's move whenever we are deploying that services in a multiple host and multiple boxes, either we container or BM or any hardware. So right now we are going to how these services communicate to each other. Communication, one of the very crucial part of microservice and very big challenge to maintain the communication between the services, either internal or external communication. External means, suppose I am the client, I am the consumer of services. How we can communicate the service as a single unit of business, because you have the lot of microservice and lot of server, lot of VM files deployed separately, individually. But as a client, I only know one domain, one IP. How we can interact as an external client, how we can interact these services, and after that, how each services communicate to each other, right? So there are a lot of things. Yeah. Before that, I will show you some. So suppose these are external client. So external client and internal services. So internal service, like there are a lot of instances of services working as a business, and they are communicating to each other for a particular task, because without interacting, no microservice generate a business. So if you want to generate the business, you have to communicate these services to each other, then it will generate the business. Otherwise, there are no single microservice, there are no meaning of business. So first of all, how to interact these things, how these are interacting to each other, one of the challenge. Each service deployed in a machine, each machine have private IP and private port. Each machine have port, IP. There are two things: location, how to locate your business. How to locate your instance. Either IP and port. There are two things required. So service might be lot. So how to manage these IP and port to each other to communicate these services? Another challenge, I am the browser. We have web-based application. One app. So app might be iOS or Android, or any client like React Native application or Angular REST client like Ajax call. So how we can interact this business application, because internally there are a lot of server, there are a lot of IPs, but as a business we have to care about only one domain, and that domain should be mapped with the IP, because we can't, because service might be increase number of instances, might be decrease the instances, depend upon the requirement. So we can't say to the client, please remove this IP. You can't call this service without. So we have to provide a layer to independent behavior to reduce the coupling between the location sharing. So how we can achieve this? So we can use one of the API gateway for external client. So what is the API gateway? Suppose first of all, API gateway. So API gateway actually proxy over the network. This is your network, and this network have a lot of services. We will discuss how they are connecting, running to each other, how to communicating to each other. right now we are discussing how to external client call these services. So API gateway actually proxy over this network. And we have to share one IP, one domain to the all clients. So our clients only know, our client doesn't care about the what things going behind, but client only know one IP, that is API gateway. So any service, any request, any port, our client only know one port. This is either 8080 or 9090, only one port or one IP that is mapped with the domain. Right? Internal, how many IPs is there? So no one care about that. No client will care. So our client just directly communicates to the API gateway. API gateway will be responsible to call the services according to the business. What request for what service. So this is API gateway, nothing. It's a proxy over the network, and it can handle load balancing as well, either software level or hardware level. So we will discuss in further slides. So we can use Joule, one of the technology Netflix library, to create the API gateway. We will see example as well. So inter-service communication pattern. So these are things. If you are using Monolith, so there no need to inter-services communication. Either we are, even we are calling the external service, then we need, but generally in a Monolithic application, we don't need to use inter-service communication channel, because each service is a part of single attribute. So they are calling through Java call or something method call. So that's a layering based system, but there are no communication required between them services. But in case of in case of microservice, it is required, because these services running separately in different machine, isolated. So how to interact we can use. So interaction patterns we can change. We can use either synchronous or asynchronous, but there's something communication required between the services in case of microservice. So we generally we are using REST API. Other example, we can Google RPC and Apache Thrift is there. We can use alternate of them, REST API. But very popular is the REST API, REST services. So how to communicate? Which communication style do we use? So it's depend also. Communication, which communication style you want to use, synchronous or asynchronous. So synchronous, I think everyone aware about that. Synchronous is just a response. We have to await it for that till now thread will be blocked. Asynchronous just call and forward, right? So it's a depend, like if you want to use synchronous, so you can see a REST call, order service call to the REST book service, and order service will wait response from the book service, right? So generally this is coupling communication. That means why it's a coupling, that means once book service not able to give the response, order service will also wait till now, and it might be failure of the system. So this is like a coupled communication. So the problem might be timeout, strong coupling between the things. So we can the solution for that, like Strix or Fin, we can use to timeout behavior or strong couplings. Like suppose strong coupling, like timeout, like might be timeout, what reason might be there? Either network slow, or hardware failure of particular service. Then many problem might be there for the different service. So we can use Strix to fault tolerance. So if particular time will wait, and after the Strix will apply the fallback scenario and return to the service. That means the particular service, calling service, will not wait for after a particular time, right? So these are example for the communication, synchronous communication, like REST, RPC, and Apache Thrift. So
Daisy, can I ask you a question? If you please go back to, say for example, one microservices is calling another microservices and there's a failure, then his strict activate automatically, or do we have to write?
Strix, actually we have to define one threshold time time of like time of how much time you have to wait. After the particular time, history will activate it automatically. It's the circuit breaker pattern. It's based on the circuit breaker pattern.
And
So
the
there are a
job
lot of patterns actually in microservice. There are a lot of patterns remaining to be discussed. So then actually that's 100 plus slides is there on high level. So we will see a particular topic in particular slides for particular topics. So we will see more in later. So
no problem. No
so
problem.
strict is actually based on the circuit breaker pattern. So what happens key, suppose we are calling a particular service, and service due to some network failure or some high frequency of request on particular service is not able to handle the service. So in that case, what happens key, our calling service will wait for till now. So we can design a sticks for 5 seconds till wait, and after 5 seconds it like hardware, like some demo, a dummy type of response will be generated automatically to the client. So
okay, so
we can
history
use alternate way. How we can use alternate way? Suppose we are calling DB and DB not able to respond, so we can generate a dummy entity to return to the, or we can empty entity we have to return on, in this case, instead of failure.
And the history layer sits on top of the service layer or on top of entire microservices?
Mostly preferable is the service layer or over the service layer, but we can use over the it's depend upon the business demand. We can also use the sticks over the controller layer, front layer, and also we can use the DAO layer. So mostly we are using, because mostly business decision made by the service layer. So that's why it's preferred to use in the service layer.
Thank you. Thanks.
So synchronous, it's a like call and forward type of thing. So the client service will not wait for other service of response. And generally it's actually, we are using some broker between them, and that broker might be Kafka, one of the example. And there are a lot of messaging queue like RabbitMQ and Kafka and other lot of. So these are non-transactional messaging system. If you see this might be messaging system transactional, but because if book service is not able to give the response, then order service have the decision to take revert the roll back the things whatever done by the order service. Suppose we are going to book a order and we just book the order, but book service, that means inventory service fail to we have to put the order, but inventory service say there no book for the particular topic. That means we have book, we have to place the order, but there no book internally. So that means if book service response returning the response failure or anything, so according to the order service take the decision, it should be place the order or should not be place the order. So this is the transactional messaging, but this is the non-transactional messaging, because the order service will call the book service and forward. Order service just book the place the order, but after messaging queue actually generate order service generate the message and pass to the messaging queue put send that message to the book service. And on that time book service said hey, there no book of such topic. Then how we can take decision, how we can revert the order or any size failure of book service. So this is non-transactional messaging system, but you can make that transactional messaging by using local database transaction management. First of things, how we can achieve this, we can use RabbitMQ, Apache Kafka, or ActiveMQ. The benefit, there no coupling between the services, automatic retry mechanism. Suppose Kafka, one of the things that is retry after one failure, and it is drawback like we are mostly depend on the messaging queue. So messaging queue fails, so then it might be problem for us to communicate the services. So we have to take care about whenever we are using which messaging queue, and we have to take care about high availability about the messaging. And message schema must be defined, because so if you are define a particular topic for particular message, so we have to define a particular format to be understand well by the consumer or producer. And we can't change the if suppose producer change the message format of particular event, then consumer, we have to change in the consumer side as well. And transaction management, one of the problem. So we can achieve transaction messaging between the message to make it the zero loss of message. How we can that, instead of direct send the message to the broker, we just save this message. Suppose if broker is failed for a long time, then we can read this message from the messaging database of service A. So similarly we can do for service B. So we can, that means we have to store our messages before forwarding to the messaging queue. Even Kafka have some retry mechanism, but it's not too much, because we have to do persistence, because Kafka contain the system like in the zookeeper. So zookeeper, one of the actually storage for the Kafka. So if whenever we push the message, so message delivered to the zookeeper, and zookeeper, we have to run that zookeeper on that time. If zookeeper failure, that means all message gone away. That means in this case we are persist the message in a DB, so there less chance to lost your message. So that's why we will cause zero message lost. Now intercommunication service, inter-service communication, how to get location of services. Till now we have seen how we can communicate synchronous and asynchronous. So that's two strategy we have discussed. Now if we are using any way, so how we can take the location of service? How does a client discover the network location of service of a particular service instance? And how do external client will communicate with the service? As I told you, one API gateway. So first of all, service registry, how we can achieve these things. So by using service registry and service discovery pattern. So in this case, we will see how we can get the location of service, how we can register the service, and how we can maintain the services without knowing the particular IP or port of the particular instance. So how we can achieve this? We need to use a cloud technology. That is, either we can use Spring Cloud here. Eureka provide the Netflix provide the Eureka server to register the services. So in this case, you can see in the diagram, suppose we have API gateway. API gateway, as I told you, it's a for communication for the external client. So every client, either browser or mobile, is only aware about API gateway IP. So that is the fixed IP. So we can't change this IP of API gateway, might be. So if we have to fix at least till API gateway. But what about the services? Services might be increase the number of instances in dynamically or decrease the instances. So how we can get the location of particular service instance? So we have get API gateway not able to remember all service IP of each services. So how we can fix these things? So there we can use service registry for this, fix these things. That means whatever we are using here, we have to register these services with the some of the registry patterns, like in the SOAP there are UDDI. So this
is it something, sorry, is it something with the service discovery registry you're talking about, or
discovery different, registry difference?
Okay, sorry. So, okay, please go ahead.
Service registry, like we have to use service registry. Service registry is like a database, and it stores the location of each services. So suppose we have created a cloud, right? In that cloud, once we are starting our service itself registered with this cloud. So you don't need to be registered by manually, or we have to make some entry in a cloud, in a DB. You don't need to do that. You just configure that particular cloud to be used in your application with the service. And once your service is started, it automatically registered itself with the service registry pattern. So service registry, nothing, is a database type of things. And it store the location of the service. Location means what is the IP of the service, what is the port of the service, what is the name of the service. it store, and it store each instance, how many number of instances we have registered. It even each registered particular, suppose a particular service have the 10 instance, so it registers all 10 instance in particular location in a database. So service instance are registered when with the registry service upon the startup, and deregister automatically. Suppose one of the out of 10 instance, there one instance is failure, so it automatically deregister. That means suppose it not chance to get that IP that is already failed, shut down. That means service registry is also responsible to deregister of that location of particular service that is failed for some reason. So we don't care about the registry or deregistration. So it only provide whatever instance provided by the uh, service registry, it will be the active. That means if 10 instances available, it provides the 10 location of services. If only out of 10, one service is shut down, so it only provides 9 services. It provides only available instance of the services. So
it's interesting, yeah.
So we can use Netflix Eureka for that. So Netflix Eureka, we have to register our services. We just if you are using Spring Boot or Spring Cloud, either one or two line of code we have to change in your application, it will be automatically registered with the Eureka. We will I will see the example. I will show you example I have how Eureka will work. Right. So this is actually service registry. Now this is actually how it's workflow of service registry. Suppose service registry is Eureka server we are using, service X and service Y. These are actually Eureka client. Our service is the client of Eureka, and where we are going to register, that's a server, Spring Cloud. So once our service X is started, so itself is registered with the Eureka server. Service Y is started, it's registered itself with the Eureka server. Now, after registering your services with the Eureka, the things are coming how we can get these services through the Eureka. Here you can see service X actually registered yourself with the Eureka, but you can see number 3, number 2. How we can, suppose service Y is want to use service X. Service Y want to connect with the service X. Then how we could connect? So you need to this service need to discover this service by name instead of by IP, by location. It's only give us I want service X. So whatever number of instances is available is responsible Eureka will is responsible to provide all available instances of service X to the Y. So how we can achieve this? How we can achieve without hard coding network location? How we can search the service? We can use 2 patterns. That's a very important pattern: client side discovery pattern and server side discovery pattern. So client side discovery pattern means suppose we here whatever I'm talking about is software level. I'm not talking about the hardware level, right? So don't confuse. So a client, if you are talking about the client side discovery pattern, so a client service find the location of other service, other instances actually by querying the service registry. Suppose is location, if a client will connect with the other service, so it will not call the directly to the service. We are not calling the service by hard giving the HTTP call and HTTP by making HTTP client and passing the IP or port to call the other service. We can call, but it should be avoided. So instead of querying to the directly to the service, we have to query to the service registry. Means service registry means Eureka. We have to query to the Eureka. Then Eureka will responsible to give the all available instance of particular services. Suppose but that particular service have 10 instances currently, then Eureka registry server will provide all 10 instances to the service. Now Eureka will provide all 10 instances. Now how we can manage these instances? Because our request only served by the only one instance. We can't say all 10 instances work for a request. Only one server, one instance will be responsible to handle the particular request, but Eureka will return 10 instances. So who can manage these 10 instances? How we can find which is the which instance have the less load?
I think
So
API gateway.
How we can find? Sorry.
Oh, sorry.
You want to ask something?
No, I'm sorry. I was unmuted. I was talking to myself.
Okay.
Sorry.
So how client service can manage that load. So that means we have to manage that load balancing at the client side. Means our service registry return all available 10 instance to the client service. Now client service have the logic, have the algorithm at the client side to manage to decide which instance of that services is have less load, which can serve the more fast request. That means depend upon the request served by the instances, we have to choose less request handler, less number of requests, which client have less request number of requests to be decide. So we have to generate this algorithm at the client side. So client application should be responsible to handle the load, to deciding the which instance of the services is to be taken to serve this request. I think you understand my word. So suppose Eureka registry server return 10 instances of particular service, right? So this is the client. We are called for a particular microservice A to the Eureka. Eureka return these 10 instances. So, but we have the single request to handle. So only one instance to be responsible to be handle this request. So how to decide which one should be collected who have less load and very efficiently handle the request. So that algorithm we have to write here, client side, to deciding which instance to be selected, called load balancing concept. Load balancing, we have to write that load balancing concept in the client side, right? So this is things we have to do at the client side. So that means client code will also responsible to manage the load balancing request across the services instances, right? So client side, it's look like this such type of. So if we are using client side load balancing, so in this case we can use API gateway, and the API gateway have the logic to handle all available request, all available instance, which instance should be called, which request should be performed by the which instance, is all logic should be at API gateway side, right? And in this case API gateway should also register with the service registry. Because why? Because service registry because instance service registry return the name of the services, instance service name of the services, account service 1, account service 2, account service 3, not return the IP of the services. So how can resolve this name with the IP? It is the responsibility of service registry. That's why in this case your API gateway should also register with the service registry. So API gateway and all services, it must be registered with the service registry. So client side, all microservices must be registered with the service registry. Its client service itself registered with the client. In this case, client is not a browser or mobile application. Client is the central point where we are calling the all services as a single unit of business. So all microservice along with the client should be registered with the server, that is registry server cloud. Client service uses the microservice name with, so as I told you, client service, that means API service, API gateway service. You're not using the, it is not using location of the particular instance. It will use the name of the service, like account service 1, account service 2, account service 3, such type of things, right? So as I told you, microservice will, or if microservice will be, a microservice will be removed from the service registry when the instance is terminated automatically. So example, Netflix Eureka, that Eureka, you know, as I told you, Spring Cloud, service registry, Netflix Ribbon. So Netflix Ribbon, what is the Ribbon? Netflix Ribbon, actually, how we can handle the load balancing at the API gateway side. So some patterns provided by the Netflix library, the Ribbon. So we can directly use the Ribbon instead of creating your own algorithm at the API gateway side. So Ribbon provide the automatic load balancing at cloud level. So we can use Netflix Ribbon to manage the load balancer at the client side. Benefit, it's very simple and straightforward to use. So like we can directly use Ribbon at the client side, and we don't need to be go in detail about the writing the algorithm of handling load balancing. But instead of this, you want apply your own logic on the load balancing, so you can apply. So client side load balancing, the benefit is that you can also apply your own logic to handle the load balancing. That's a benefit. But drawback couple between the client code with the server side code, because you should client code matlab API gateway should also register with the server side registry. So itself that means coupling between the service registry server and the client code. So it means client code should register with the should be registered with the server side registry pattern. Okay, so need to implement discovery logic for each service. That means suppose if you have number of API gateways, so for each API gateway server, for each API gateway application, you need to be write that load balancing code, whatever you made change for calling the instance of particular microservices. So you need to be implement that logic for each service. That is something drawback. If you want to use server side discovery pattern, so you know clients is not able to in this case clients should not be registered with the service registry. There's no necessity to register with that, because we are using separate server, separate hardware or server software level load balancing. So in this case, we don't care about the how we can manage the load balancing, how we can discover the services. So that is a different we can say there different application might be there or different server might be there. Sometimes calls like a load balancing hardware level load balancer, they are called
kind of Nginx and all.
Nginx, right? Nginx, or there are many is available. So if you want to use such type of things, so you don't care about that. So you just create the client application, or through that application Nginx or will handle for you. So you can see, you just call REST services through the Nginx. Load balancer is a different server load balancer, but in that case, the load balancer server must register with the service registry, because whatever either client application, either load balancer, anyone who want talk to the microservice, it must be registered with the service registry, either client or load balancer, separate load balancer. So it must be registered with because without registering with the Eureka service, you can't call a service by name. If you don't want to register, you can avoid this registration. But in that case, you have to call each service by location, like IP and port. In that case, you don't need to be the service registry. But how we can handle such number of IPs, such number of port? So we have to use service registry.
Dinesh, I'll just ask you a question on this slide, please, if you don't mind. So basically, if I'm planning for a microservices implementation for a small project where we have one or two, say for this one. So first, we have to create a service registry, or first we have to create a load balancer.
Load balancer actually we
first
can
boot application will be which one?
Right. Service registry, actually service registry, one of the application that is actually server application, Eureka server application you need to create. So load balancer, one of the things that is handled by the DevOps teams. You can share your IPs and it will set up for load balancer.
Okay. Okay. So question is simple here. So first of all, if we are planning for a small microservices project, you have to create a Spring Boot application, which is a service registry having Eureka Netflix enabled, correct?
Right, right.
And there you will register all those subsequent small piece of code like as a service.
Right.
And also, if you want to use API gateway on that project, then API gateway has to be deployed later on or initially right after service registry application?
Actually, need of API gateway if you are using NGI and X. So in that case, you don't such requirement of API gateway. But in case of you're not using NGI and X, or then you can go with the API gateway. API gateway actually what happens in this case, if you are using NGI and X, so load balancer actually responsible to manage all behind IP or port of this all services. API gateway, nothing. API gateway actually provide the virtualization a proxy over the network.
Yeah,
API,
I understand. So my question is simple here. My question is on what step we have to see load API gateway is again a small independent application.
API API gateway. If you are using API gateway, then API gateway one of the single point of failure might be. So API gateway you should be it's a more highly available application. So you must care about the API gateway because all traffic whatever we are throw to our application goes to the one way is the API gateway.
Yeah. Question is different. Question is API gateway is a small piece of application which we have to deploy, write and deploy, or
it's totally configurations. It's some configurations and some rules. We just some property files. We have to write some rules, and we just have some mappings of the services. That's it only.
Yeah. Okay. Thank you.
Actually, what happens if you're not using API gateway? What happens? Suppose account service we have deployed. So account service have own context route like localhost 808 account then application port. Similarly for order service, localhost some port and order service then / some application interfaces. Same for setting. So in this case, the context route is different for each of application. But if you are using API gateway, you just one context route like / API and call service name directly. So single context route we are mapping all applications. That is the benefit of API gateway. So actually API gateway actually not only providing the load balancing, API gateway is providing a lot of things. So we can also use API gateway with the load balancer as well. So we can shift that load balancer, how we can manage the load to the NGINX, but virtualization over services or services network, we can use API gateway. We just remember one context route API / API. So internally API gateway application manage all things. So API gateway doesn't have any code like no controller, no repository, no service. It's only configurations.
Okay. I understand your point now. Okay. Right? Thank you.
So load balance server that separate from the client service. So here, NGINX is different things. It's not part of our application. The client service makes a request directly to the load balancer, which queries through the service history. So, यहाँ पर network, there's a network latency is there. Might be because we have to we have to go load balancer, and then load balancer talk to the service history. That means one step we have introduced one more step. So network latency might be region for that. Then it has more network rounds actually. So that is a drawback. So, and we also, if you want to customize some load balancer things, so we can't do, because NGINX different server. As a developer side, DevOps teams will handle for that. So we can't apply our own logic on the load balancer side. We can't do that if we are using server side discovery pattern. And also load balancer is highly available things. Similarly for API gateway, if we are using API gateway, then API gateway should be highly available. If you are using load balancer and NGINX, it should be highly available, because it's a single point of failure. Benefits like client service doesn't care about the logic behind the load balancing. So it's just call the NGINX, so it's managed to all other things, whatever required, non-functional things. Right. And as well, no need to write client service for each service, because the centralized discovery logic we can put on the NGINX. So client service is not responsible to call write the discovery logic of each services. So client service is very separate from that. I think the discovery pattern we have discussed till now. So several, we will see these things in an example. Right now we are high level, we are seeing, we will see these things in practically, so you can correlate these things with the practically very easily. So right now, how we can test a microservices. So microservice, as I told you, if you want to write the test cases for microservice, if you talking about a single microservice, JUnit testing is very simple. Instead of comparing with the monolith, might be in the monolith might be something problem, because there are a lot of dependencies, there are a lot of code base, there are a lot of code base complexities there in the monolith. But in the testing of microservices might be very simple. So because JUnit test not much required for microservice, but integration testing is required for that. So how can make it test easier? So individually we can test easily, but it's difficult to test as a application end to end, because biggest application is not within the complexity of itself. Complexity is not in the microservice, but complexity in the interaction of microservices. That's why integration testing is difficult. So these strategies actually defined by the Spotify. They are one Spotify company. So actually they are using such type of strategy, because microservice, as I told you, is not a silver bullet, is not a hard fast rule. So each concept in the microservice is depend upon the companies, depend upon the architectures, depend upon the business. So we can decide easily. So Spotify using this strategy. So if you are talking about the pyramid strategy, it is easier for it is much suitable for monolith, because unit testing in the monolith very much required. And then after the integration, because integration not such required as unit testing required in the monolith, then integrated. So but in case of honeycomb strategy, it's a microservice. Spotify adopted this strategy for microservices. Implementation determines unit testing. So it's according to the Spotify, integration testing must more required instead of JUnit. So you can write less number of JUnit test cases, but you have to test your part. Integration testing is highly required. Then integrated. Integrated testing means end-to-end testing as a single application. So, but there are another strategy, microservice by pyramid. If you want to use pyramid strategy, so we can redefine that particular pyramid strategy for the microservice such cases. Like you can write unit test cases. That test cases, within the classes, JUnit test cases, everyone know aware about that. Integration just like it's test inbound and outbound adapter. Like Integration testing is only about how layers interact to each other. If we are in a monolithic, in a case of a microservice, how microservice communicate to each other. Contract testing means there one consumer service, another producer service. How which contract pattern, which number of what input, what desired output, what desired input. So input output, whatever contract defined between the services, the testing of contract. In which format we have to send the request so service B can accept it. So this is testing about the input and output format. We can say messaging. In case of messaging, component, it's actually if it is actually whole microservice testing is as a single component. If we have designed a service and we want test whole service as a component, it tests entire service in isolation without interacting to each other. If there are any dependency between them, other service, we can mock that dependency. We can create stub of that dependencies. End-to-end testing, just like it's a full complete testing for end-to-end for a business application. You can see testing of microservice in JUnit testing. So it's a unit of parts we have to test in a method of line number of a class or line of code. You can see pink color oval. So resource, service layer, domain, and gateway is it's like JUnit test cases. In a particular layer or particular class, we have to write some piece of code to test particular functionality. So you can see here. So how we can create the microservice JUnit test cases. So it's very simple. I think everyone aware about that. So we just create a mocking. If you want to create the some thing, we just create stub data mock. We can use Mockito, one of the framework to mock the dependencies in the JUnit. Integration testing is like it's a very opposite to the unit testing. Unit testing use the functionality of particular code, but unit testing, integration testing is not testing the functionality of particular. Integration testing is test how our service, how our application interact with the external or internal things like database or REST APIs. So you can see integration testing here. So whatever covered with the red dotted lines is the integration testing. Suppose this is the external service. Our microservice is called that external service. How interaction between them? So we have to test this part. ORM and DB. DB, you know, DB is the external things for each microservice. So we have to check our DAO layer with the DB, how we can interact with the DB. So external things, external services or external database, we need to be verified how we can communicate to each other. So this is the one from REST API integration testing. Suppose we are having a dependency with the external services. We have dependency with the external services. So you know how we can call the external service through the REST API. So how we can write the test case, integration test case for REST API integration. So in this case, you can see the code we have used mock MVC. One of the that is a Spring provides. Spring, you know, Spring only support the integration testing. Spring doesn't provide any library for JUnit. Spring will provide the library for only integration testing. So here I'm just creating an integration testing for controller and create the mock MVC and account repository and just make a REST call for a particular perform a REST call for particular account and just some account ID, and we have we can expect and output such type of whatever we have written. So we have to expect a JSON whose pattern matching and we have hard coded, right? So status should be 200 type of things like 2xx like 200 status. If we want to perform DB integration testing, then we have to write at the rate data JPA test, and you need to be perform this test. We have just create a new account and we have saved that account in the repository and then perform the find account by ID by same ID and match with this both account. account V is account A. It must be matched. That means we just create a user and save to the database and fetch that same user and match both object. It must be matched. That means integration testing with DV. Contract testing is all about how we can design our input and output, so that two service, one consumer service, one producer service, to accept this input and output each at the time of interaction. So integration contract testing is all about to test our input and output between the producer and consumer. You can see this example. So our consumer A, consumer B, consumer C, and one producer is a big smiley. So it has some pattern, like some information about the book, and it has ISBN number, name, author name, and this is the format whatever producer will produce. And check contract with the contract A, contract B, contract C with the three services: consumer A, consumer B, consumer C. These are three services. Check this contract, it is acceptable or not. If each service is accept this contract, that means it's successful testing. If suppose any one of the service is not accepting this contract, that means either problem with the producer or problem with the particular service. So we need to be correct that. Component testing. So component testing is something like matching with the beacon. If we can combine JUnit and integration testing both, like component testing in isolation. So component testing means in testing of a particular microservice in isolation. Suppose particular microservice depend upon the different service, depend upon the some external functionality, then we have to create, for that we have to create a mock. For that we can create a stub object, for that dummy object. Suppose we have database. If particular microservice using a database, so what is the alternate of that database? We don't want to go external dependency. So we can use in-memory database HSQL or H2 to test the particular machine, particular microservice in isolation. So we just configure in-memory database and we can verify that our functionality. If suppose we have some dependency with the external services, in that case we need to be verify. We need to be call a REST API. That REST API will return a particular data of JSON. So how we can isolate such type of dependency? We can mock that JSON. We can mock a object. What is expected object of particular REST API? We can mock that object internal inside the microservices. So component testing is about testing of a microservice in a isolation without interacting external part like database or services. If dependency is there, then we need to be mock that dependency. In the case of database, we have to use in-memory database. In case of external API calls, we can mock that API in the internal. Right? So you can say external service we have dependency. So we just stub the REST API. Whatever output of that REST API, we just stub that REST API. We internally make some hard-coded output of that, expected output of that API. In case of DV, we use in-memory database. You know, in-memory database no need to be defined in externally. It's just in-memory database inside the application. I think everyone is aware about in-memory database. End-to-end investigation, testing is like Selenium. You know, I think you are aware about Selenium test cases. So develop mostly QA members writing the Selenium automation test cases and run in the morning, every morning to sanitize, like sanitize the, so make the sanity over the build. So it's about the end-to-end testing to verify the business behavior. So we have some input that need to be put in our business, and what will be desired output of the business. So it means we have to just verify the business goal. That means for what I have created the software. End-to-end testing end-to-end testing is required for that, right? So it's such type of integration. There are a lot of microservices, order service, account service, book service are working inside the application. We just write a Selenium script and run over the application. It run automatically and generate a report and send to the particular emails. What test cases fail, what test cases pass. Now we are moving to the discuss microservice anti-patterns. So microservice anti-pattern, in this case, we are going to discuss what things should we take care about whenever we are deciding to design a microservice based application. So there are some of the anti-patterns I want to discuss with you. So that's a distributed monolith. So distributed monolith means we have to take care about whenever we are designing the application. That means at the time of application decomposition, we have to decompose a application in such way that a common functionality should not be applied in each services. We have to avoid this such type of things. If any common functionality is applied in all services, that means we need to be decompose our application again. Like you can see it, distributed monolith. There red mark blob. That red mark oval is like a common functionality that is applied in each services. This is a common functional logic into one or more services, two or more services. If such type of things is there, that means there's something or we have missed something, business understanding. So either we need to be understand business more, then we can decompose again. Either we can decompose that common functionality in a single application. We can apply a common closure principle, I think CCP. Yeah, apply common closure principle. That means for all common functionality, we have to write a different service, and then we interact the service via REST API for that particular things, right? And we have to write things in a together. Things that chain together should be picked and packaged together. That need to be applied CCPL principle to avoid distributed monolith. That doesn't mean there are a lot of developers saying, yeah, I have to write that code in a particular microservice and I don't want to create new service because there are a lot of hectic. We have to create service, then deploy. So manager will ask, a lot of things might be introduced. So what happens? Developer will just create the same code, just copy paste in service, check out the second service, copy paste second, third. So just check out, just from the git, check out and push. That means it's like make it after some time, it make it distributed monolith application. And each application has everything. You can deploy any application, you can find business goal. So have to avoid this such type of things. We need to avoid common things to introduce in each services. If any things that is common, we have to write a new microservice. And different anti-patterns is immature communication strategy. Immature communication strategy means sometime happens user will understand a microservice as a programming interface. What happens? User just want to talk to other service. So what happens? Like a developer just get the IP of the particular service and just make the HTTP client and call. So this strategy, communication is very immature. You can call, and that call also give the response because internally REST template also using HTTP. But this is immature communication behavior. So if order service want ask to the account service to get the data, then we call that service through the proper communication strategy via using service registry or discovery pattern, all of other things, instead of directly call order service via HTTP client. So treat a microservice as a microservice, not programming level module. Don't communicate with any microservice via using HTTP directly at the programming level. You no need to create just like HTTP, make it HTTP client and call, pass the IP and port and just call and it will give data and you can use. Your work is done. So that your work is done, but sometimes make a hell. So you can't able to understand how we can resolve this issue, because suppose this IP and anytime this IP is not available for your machine. So how we can handle this, because you don't aware, suppose developer is like resign and go away. So how we can understand from where is problem is coming. So we avoid to immature communication strategy. And also focus to reduce temporal coupling between the services. Why it's a temporal coupling? If you can see here, this is a temporal coupling. Suppose we want to post a order and order against a account. So before the posting order account, you fetch the account. Account service if able to respond able to respond, then you can easily post the order. Suppose in case account service is down, then in that case you can't post the order. So in some cases you can avoid that temporal coupling, you can avoid, because every cases you can't avoid, but some cases whenever you can avoid, you can do as much as possible by using synchronous behavior, synchronous communication strategy. So this is actually immature communication strategy should be avoided by using these things. Anti-pattern, one of the very big shared database. Mostly company perform this mistake. So we have the multiple microservices and we have used shared database. For example, account service want a order data. Suppose a account service have customer data and we want to read the order of the customer from the order service data. Means we have the two tables, account service table, account table, order service have order table. If you account service want data from the order table, you can't directly use account service by making a call to the query SQL or SQL call to the database, order database. That means you are sharing the database in different microservices. So whatever requirement of, if you have requirement of order data, then you need to be called order service. Then order service will provide data of particular account. So you have to follow the proper way, communication way. You can't use shared database. So avoid shared database things. If you have required the data of order, then you can make a call through the REST. So mostly use database per service. Don't mess up the databases. Each table is only accessed by single service. We can't couple multiple services, not able to depend upon the single table. If anything required to that table, go through the REST without direct, instead of calling directly database, right? Unencapsulated services. So that is one of the very mostly pupils make that mistake. So what happens sometime, suppose you want to write a REST API and you want to expose that REST API over the network. So there are a lot of logic might be there. So some developers, what happens, doing like DB code or service code at the control layer. They won't write the controller layer code, everything in the control layer. So we should avoid this type of things. We expose the service API as much as minimal. We don't need to be expose our business functionality at the service API level. We just put that functionality as we can hide that functionality as much as possible. Abstraction, we have to use abstraction as much as possible. We have to abstract your business layer as much as possible. We just expose only service API for query and command only. We don't write query at the service level, service API level. So whatever we have discussed, There are a lot of entry patterns there, but I'm selecting only 2 or 3 entry patterns. But we have to avoid these patterns to make your microservice and summary. We have discussed microservice architecture, many other architectures. So microservice actually provide the agility in development, frequent development, reliable and testable. So it is not silver bullet, as I told you many times. So it is it has some challenges, it has some benefits, right? So we need, it's depend upon the our decomposition behavior, how we can decompose applications. So along with it's introduce benefits and challenges. Decomposition is one of the challenges to decide how we can decompose our application based on the business capability or domain. It depend upon the how number of public operation we have to perform. So our business capability has less number of public operation, then we can decide a business capability as a microservice. If a particular business capability has a lot of public operation, then need to be decompose that application, right? So deployment pattern, as I told you, choose as per as your requirement. So there are some benefits, some drawbacks. So accordingly you can decide, because it provide a lot of flexibility to deploy. We need to care. We need to careful service interaction. Yeah, service actually when we have to use synchronous, when we have to use asynchronous, we need to be careful whenever we design this communication strategy. So it's also depend. As much as possible we have to use asynchronous communication style, because it provide non-blocking calls. Service discovery, as I told you, is searching the service and how we can register our services with the service registry database. So we can easily find this instance by a service name. So I have finished these slides. So any question if you have, you can ask, and if you have time, then I will show you one examples in a MSc.
Dinesh, no, thank you very much. I don't have any question. Actually, I have something else scheduled now. So thank you very much. I'm leaving now. I'll
Okay,
probably
thanks.
catch up through emails and all.
Thanks.
It was a wonderful presentation and training, to be honest. Thanks. Please keep on repeating these kind of things.
Right, obviously.
Thank you, and bye-bye. See you guys. Bye-bye.